Welcome to Solidworks 2016 training series. This is the most updated training series available till date, and this productivity directly can increase your ROI over the projects. And mostly, I found in my last 18 plus years experience that the SolidWorks is used in mostly the SPM design or any design where you have a requirement of frequent changes and you have maybe the top down or the bottom up approach, and this is widely used in R&D engineering and using the design portfolios, and also the wide variety of domains where you can find this particular software handy. And one of the important thing which I would like to highlight here is this particular software is also one of the product of Dassault, and when you want to migrate from SolidWorks to Dassault product also, you will find very smooth transition. And this is one of the very widely accepted and popular software among engineering community. And to be precise, the course objective is like this, and we'll look at this fundamental of parametric modeling of SolidWorks 2016, and the course we have designed by keeping the fundamentals to advanced application in mind, and also we have included industry standard projects to better grasp and apply the concept while working, sketch to part, the assembly, and other modules we have covered, sheet metal and drafting, and also we have included many other modules which I will show you in my coming course objective slide. And I am Pravit Kumar Sanapati, subject matter consultant and author for more than 100 plus e-learning online contents in CAD/CAM CAE domain. And since 2000, I have trained more than 35,000 engineers in classroom and through WebEx. And since last 5 years, as I was involved in the course development, and also we are present in 55 plus countries, and also trained through this course where more than 10,000 engineers as well. And you can follow me through my LinkedIn and Facebook profile, and socially you can get connected and you can get more details about the upcoming events and about my plans. So let us directly dive into the agenda here. So who are our targeted audience we'll be discussing, and what do they do, module highlights, prerequisites for this course, and we'll be also looking at one sample course preview, and finally we'll discuss deliverables. So let us start with who are our targeted audience, and you may be wondering who are they. And before diving into this particular concept, it is always evident and important to know why you learn this particular course and who are qualified for learning this, what is the best way to learn this, and when you can learn this, and typically this application program, how you can take the benefit and learn that. And if you look at the targeted audience is the application engineer, design engineer, CAD, CAE, CAD engineers, and CAE engineers, development engineers, R&D engineers, product design and development engineers, project team leaders, GM design or the team lead, CAD trainers, tool design engineers, and also the die and fixture, or you can say all the work related to your domains where you create the fixtures. This can be very handy. And auto domains designers, aero domain designers, product design engineers, and mostly very important is the SPM designers, the special purpose machine. This is widely used, and CAE analyst, they can use this particular tool for migrating the product to CAE environment, and this is very useful. And consultant in CAD/CAM CAE also use this. And what do they do exactly is very straightforward. And they primarily start developing new or modify the existing product by using this particular tool. And applications of CAD/CAM CAE concept for product design also is one of the important aspects why they use, and they analyze the user need end-to-end requirement and then develop the engineering solutions. And also they analyze the design configurations for the product and recommend the changes and finalize the solutions and customize the engineering applications to automate the process. This is very important so that we can reuse the existing part and then we can also take the leverage and analyze the manufacturing process and recommend appropriate plan and optimize operational efficiencies. And you can use and customize this basically for product lifecycle management, complete product design to end launch and all intermediate process, and create technical specifications and test plan as well. And also you can create appropriate documentation to ensure traceability from concept to the retirement or the obsolescence of the system and your subsystem as well. So this is what mostly the job responsibilities or what do they do and the overview. And let us look at modules highlights. SolidWorks 2016's module highlight is here, and I want to just highlight one point. Mostly 55 designers or the engineers never ask for course details before learning CAD/CAM CA course, and which looks like funny, and you need to be precise and you need to be serious about this, and we are. And let us discuss about our modules, and 22 different modules we have covered, starting from the introduction and then going to the sketcher for the solid modeling, editing and modifying the sketches, adding relations. This is very useful and handy. And the dimensions of the sketch, advanced dimensioning technique and base feature option. The feature options also will be discussed here, and how to create reference geometries and fundamental of advanced and editing features, advanced modeling, again more advanced features, and this is also again more advanced feature, and assembly modeling fundamental and advanced, working with drawing views fundamental and advanced, and surface modeling working with blocks, sheet metal design, equation configuration library feature. This is very useful, motion study and mold design introduction, and productivity tips and tricks. So these are the 22 different modules which you will get within this complete course. And what about the prerequisite? Prerequisite is very simple. This is one of the important aspect as far as prerequisites are concerned, and modelings, this particular concept means mostly engineers interpret it is all about drawing to part components conversion. No, not at all. I'll teach you how you can effectively can design, and if you could visualize 2D sections, then you have prerequisites for design CAD packages. Let us look at one sample course preview, and under this sample course preview we'll be looking at advanced modeling tools, and the concept mastery will be our primary focus. So these are our learning objectives. The sweep features will understand how to create, and also we'll look at loft features, create 3D sketches, edit 3D sketches, create various type of curves, extrude 3D sketch, and create draft feature using manual and draft expert method. This is one of the advanced option which also we'll be discussing this particular option. And let us start with this particular concept under this advanced modeling tool, creating sweep features. So if you start learning this sweep concept, and already in CATIA or NX or Creo or any other package, you come across like the same features or the facilities. So here you have one profile and you have one path, and with respect to this you are going to execute and create your object. And this is something like this. So here you have the profile and the path, and here you can see the preview is about the cross section. So under this you'll be selecting the cross section here, this, and under this you'll be selecting this particular path, whatever the path you have. And you have other options like the guide curves, the start and end tangency, this, and thin features and curvature display, other some advanced option. But let us start with this basic understanding how to configure. And some cases, like if you have the sketch and the profile not at the same place, that also you can use as the guiding curve. Or if you have path and profile both are closed, how the output will be, that also will be looking at. And also if you try to understand the some advanced option where the follow path option and how to control this end tangency, here you can see in this both cases. So here you can see the follow path option is selected, but here the keep normal constant option selected from the orientation twist type. So how the differences are and how you can take the advantage, that I will show you. From your exercise file directly you can get this particular file, and that you can open like this. From here you can see the exercise files. So let us start with this particular file, then we'll move to other one. So here this is attached and here this is not attached, both the scenario we'll see. So once you open this, directly you can start using this particular option, and here you can see the sweep option. And once you select this, here you can see two options. One is sketch profile, one is circular profile. And in case of circular profile, this is the completely closed one. So let us start with the sketch profile and select our profile here. Once you select and click here, this complete profile will be selected, and then that will directly navigate to your path. And when you click your path, what happens is this output will be shown, and here you have other options like the guide curves, like other options like follow path or keep normal constant. If you go to keep normal, the scenario is different. If you go to follow path, it's going to follow the path. And if you can go to profile twist, specify twist values, and based on the twist values you can get the twist also. Let us say 45 degrees, and this you are going to get that twist. Or maybe you go for 90-degree twist, or maybe you talk about the higher twist, and I will finalize this. And here you can see this is the twist which also you can assign during your creation method. And this is the basic task which you have to start understanding when you go for the sweep option. Let us look at the another example where we try to understand when the path is not exactly attached to this particular case. And let us say the particular your profile which you are considering and the path which you are considering, you can see this getting mapped with respect to that. And if you can follow what I was discussing here and the follow path, this is another example, but if you directly see this particular case, the resulting sweep will be this one. And in case of your profile, if you just close also, this is the case. But we discuss another case here where we can directly go to follow path none, and another case we are going for keep normal constant, orientation and twist type drop down list, and you can also control that we'll see keep normal constant option selected, and we'll discuss that as well. Let us look at another example, this, and here also is exactly same. The thing is only the profile is closed and your path is closed, both are closed. And here you can see this and this. This is the output which you can directly see here, preview, and you can finalize. Let us look at another example, this one which I was discussing. So when you go to the sweep feature and you select your profile and then you select your path, and here you look at the guiding curves, and currently we are using this option, and under this option what I will do is this follow path I'll just change to keep normal constant, and you can see if it is normal constant is maintaining, is directly merging this, it cannot follow again, and this is the option. And if you go to specify twist values, here also along with that you can get the twist values as well. And finally you can accept this and you can see the twist values as well. The whole picture will be treated. So this is advanced option, you can tweak and play around this to get critical objects, and you can check that as well. And in our next exercise we'll be looking into some more advanced features and where we'll be looking into that. So let us look at this particular concept where we'll be looking at the sketches and the path and the merge with respect to the existing feature, and how to align the end faces and see the merge result, and also the tangent face. That complete typical configurations we'll be looking into. And this is another example where the sweep feature created with the align with end faces checkbox, you can see, and this is the resultant output where you can see this exactly merge to the both the end, and this is basically sweep feature created with the align with end face checkbox. So let me show you both the things so that you can better understand this. Let me open this particular example where I was discussing this particular case, and here the first operation will look at this, the you can try this sweep cart as well, but primarily here I'll show you this particular operation. If you could try to implement this and the path, and here you can see the start and end tangency. The start tangency type is the path tangent and the end tangency is path tangent, and if you just finalize this you will see no difference here. But let me show you what exactly I mean. But if you just switch to options and select this align with face, you'll see the difference. So why this is not applicable is this a typical tangency option, and here there is no tangency, and you have to understand this. So wrongly if you try to apply this also, nothing will happen because this is not the case which is applicable valid for this. So if you go to align with end face, then directly you can see. And if you have a tangent faces, then you can use this merge also. Here there is no tangent face again, so again this is not applicable to this case. So this is one of the case where you can check this type of conditions. Let me show you another example. Go to the sweep, select this and select the path. And here if you go to circular profile, what happens is directly that cross section will be treated as a circular profile, and here you can directly give your dimension whatever you are looking at. But if you go to sketch profile, so just like before shown, this is directly converted and this will be done. So sometime you can have a circular profile and only following a path and giving the dimension, and that can be handy and that you can use. I was discussing before this particular twist option as well, but here I will show you some options which can be giving like this output where you have the twist along path and twist along path with normal constant you can also use and you can give a higher twist protocol. So let me show you what I mean. So directly you can apply this to this, and you can directly go to your this options, and you can go to profile twist. Here you have like specified twist value, specified direction vector, and tangent to adjacent faces, and these are the options. So if you go to the keep normal constant, this is not valid here. And if you go to follow path and go to specify twist value, again when you go to twist values, here you can see degrees, radiant, and revolution, that all you can see. And you can have a merge tangent faces as well. But let me start with this particular feature where I'm giving 1200 degrees, or you can go to other values like radians and revolution also, and you to have 5 revolution, so that will give you output. So this particular option, if you take, nothing is happening because there is no related tangent faces, so this cannot be applied. So primarily this particular option you can check either by going through your degrees, or maybe through the radians, or maybe through the revolution, and you can find your final output like this, which is shown here. So I was just discussing another option where I could show you this particular sweep feature, and where we have the along the path with normal constant. So twist along the at this particular option I was discussing, and how to use that also I'll be showing you. So if you just edit this edit feature to see this exact mapping, I'll be showing you through this exact example where you can really see the difference between the twist and normal option. And I'm selecting the cross section and the path, and here directly if you go to this option, here you can see the follow path and keep normal. So these two differences I was discussing here, the normal constant and the follow path. So if I'll just zoom this, so clearly you can see the difference. Let me start with specified twist values, and twist value is, let us say, some 360 degrees. And here you can see the difference. Once I'll change this to keep normal constant, it keeps this normal with respect to that, and you see the cross section size here. When I'll go to follow path, it follows the path, and finally the shape is driven in that direction. And the options like twist are same in both the cases. Just I'll change this, and you can see the output. And this is the fundamental difference between these two different types of option. And also we'll look at the sweep with guide curves. The guide curves option just I was discussing, and when you'll go to profile, path, and one guide curve, then you can also create a complex shape like this, which you can see here. And when you go for advanced tweak, like sweep with the path and the guide curve for creating the sweep feature, and the resulting sweep feature can be also shown. So if you want to try to merge this particular end, how to get that also I'll be showing you. And then we'll look at some more advanced options. Let us open this particular file, and we go to the sweep. And when you go to the sweep, here you can see this existing option which we have not used before. And this is my cross section, and this is my path, and this is my guide curve. And when you update the guide curve, here you can see. And also if you go to this option, here you can see the follow the path or keep normal constant. This also you can apply here. And merge tangent faces, this also you can apply here, but you have to see the typical case where you can merge the tangent faces wherever the tangent faces you have. So if I'll just little bit zoom it, you can see the difference. if there will be tangency directly, this will be driven. In fact, if you remove this merge smooth faces, so then it will create you a features like this which you are seeing. And if you tick smoothen faces, it will smoothen the curvature as well. And here I'm not seeing any difference in using this merge tangent, because this is a typical non-tangent case. And if you are using some circular cases where another profile is tangent, then this can be handy. But in this case, this is not useful at all. And this is one option. So I was also discussing about the another case where maybe this is the case where you want to connect this end with respect to that, the guiding curve or this, or you can just go for the reverse also. Then how to handle this type? You can see the downstream feature may fail due to changing the merge smooth face option. So do you want to accept the changes? And in that particular cases, you can avoid and you can fix that as well. And you can see some of the features which looks like this. So let me show you what I mean. Same example we are using to understand the reverse scenario. And in this case, what we'll do is we'll keep the profile as before, but we'll switch this particular path. Instead of this one, this will be our path, and the guide curve will treat this as our guide curve. And in this case, what happens is this is the output, and when you go for accept, this will be the updates. So it will follow this one. So because this is your path and this is your guide curve, so anyway, it has to approach this one. So this will be your resulting output. Let me show you a couple of more examples here, and we'll be discussing about some advanced option here. And you can find the merge smooth face which I was discussing before. And this is the example where I can show you exactly what I was discussing before. And here you can see the sweep feature created with the merge smooth face checkbox selected. So this merge smooth face. And this is basically merge smooth face checkbox cleared. And you can see this is not merged still, the spines of the curves you can see here, visualize here. And here you can see show section curve, where you can see these are the sections which we took for forming this. So these sections you can find in this corresponding places if you use these show sections. So all these three different options I'll be showing you. So we'll be opening this particular model file, and after that we'll look into what I was discussing here. And here uh, when you go for the this sweep operation, and I'll start selecting the profile and the path, and here I'll go to the guide curves and select multiple guide curve number 1 and guide curve number 2, and you can see this is the final output. But exactly I was looking at some other cases. Here you can see when I'm switching off the merge smooth faces, it exactly smoothen these faces, which you can see from here as well. And I was talking about the curvature display. Here you can see the mesh preview also, and here you can see the other features where the flow of the surface also you can see, and the curvature combination also you can find here. This is one of the option which I was discussing. And here directly you can configure these options, and you can get all these features which you are looking at, and you can switch off anytime any particular operation, mesh preview, and you can finalize this. And in this way you can check and create this type of critical feature, but it is very And here also you can select this red crystallization, and you can control all, also show all curvature compose, and that just I shown before, and hide all curvature combo, and this all show section will be shown once you select this particular operation. And here you can see merge tangent face, this option directly you can highlight here, and these are the complete options set which you can find here: the guides, your path, your sketch, and the merge smooth options, so which I discussed here. And you can see if you look at all these different options which I was talking about. Next we'll look at some of this feature, sweep feature, using the follow path and the first guide curve. Here you can see the first guide curve, and this is your second guide curve, and the center one is your path, and this is your profile. And here what will happen is you can create and the subsequent this, if you go for the follow path and the first guide curve, and this will be followed accordingly, this particular feature. And if you go to first and second guide curve follow, then the combination will be different. Here you can see follow the path and the first guide curve, and here follow first and the second guide curve. The complete output will be different, and typically that you can see. And this is one of the handy feature which you can see, the sweep feature using the follow path and the first guide curve, or follow first and the second guide curve option. And this basically can directly save your time in altering, and you can directly start doing that. And also you can control the tangency here, the start tangency and the end tangency. And then we'll look at the thin features as well. So let me show you what I mean by this. Let us open this particular exercise file, and here you can see this is the typical output. And if you go to this, here you can see the sketch, and here you can see the path, and now you can see your guide curve, and here is the guide curves. You can up and down this guide curve also if required. And let me show you this, and finally this one. And this is the typical output. And also you can switch on or off, and primarily this will be your output. And here you can see like the merge smooth object, switch off or switch on, and you can see this is the corresponding output. But let me switch a couple of things here. You'll just go to Control G to undo this. And the thing here is, if the first guide curve among this, whatever you talk about, so suppose this is the first and this is the second and this is the third, instead of this profile or the center path, you just switch this to this one. Let us say, what I mean is, if you go to this and go to your section, and this is your path, and the guide curves are other one, this and this. So these are my guide curves. So what happened is not able to produce the output because it is completely ambiguous. Because your path, whichever you have, if you remove all this, let us say, you see your path is following this one, this typical path, the curve, and your section. But when you go for any of this as your maybe this as your guide curves, then this is violating because these both are sitting over the same plane. And let me remove this and select this also. So the guide curve, when you're selecting the center spine, this absolutely violating. Then how can you create this type? So here the concept is something, the sweep feature created using the follow path and the first guide curve. the follow path and the first guide curve. Here you can see the path and the first guide curve, and this is the second guide curve. So always the path is this one, and this is the first guide curve. And if you switch that, the follow first and second guide curve, then that will be the different protocol. So let me show you what I mean. The first and the second guide curve. And of course, in all the cases, your path is this. Let me remove this. This is your path. And your first guide curve is, let us say, this. Or I'll delete it, and this is your first guide curve. You can see this. And this is your second guide curve. You can see this. Or I'll just delete this. And this is my first guide curve. And this is my second guide curve. And you can see how the continuity is maintained. Again, I'll delete. This is my first guide curve, and this is my second guide curve, and accordingly that is adjusted and maintained. And you can add also multiple curves as per requirement, or you can just delete this, and maybe this is my first guide curve, this is my second guide curve, and this is my third guide curve. Secondly, that will be maintained, and which one you need to select or you deselect. Maybe this particular guide curve I don't need, and based on that you can have it, or this particular guide curve I need to remove, and only I need to add this one, whatever the combination and alteration you need. So based on that you can see the output will be accordingly considered based on your type of guide curve. But center one, this you need to understand that this is the center spine, so it has to be within the sketch or at the central location, and other guide curves has to be around the periphery, which will act like your guiding curve, or you can say the ribs, or you can say the support, etc. Let us look at this particular operation where we'll be looking at the thin features, where you can have the thickness, and you can have your path, and you can have your cross section as well. And already I've shown you before this the mesh, the zebra strip, and the curvature, and that you can also try here. And let me just show you what I mean. And once you try this you can apply to any of your cases where you can find this handy. I'll just close this and I'll open our file, this one, and let me delete this particular sweep, so that you can see this is the basic feature. And when you go to this sweep and select your cross section and your path, and here you can see one option known as thin feature, one direction or mid plane or two direction. One direction is any one direction away from your sketch. If you zoom this, you can clearly see this. I'll just look at mid plane. You can see the sketches are the mid, and both side the 0.5 is allocated out of this one. Or you can have two direction. One direction is 2 mm, whereas other direction is 1 mm, so collectively 3 mm. That also you can do, and these are the different options which you can see. Here you can see. So thickness protocol for this sweep is very important, and in most cases, instead of directly going per shell, per removing material like this, which we'll see in our coming session how to shell this, but directly what you can do instead of this shell, create with a thickness. That is very handy, and you can use this. Next, we'll look at this important feature which is known as cut sweep feature. What is the difference here is, what you do in case of cut feature is, this is also one sweep, but in fact what you do is, with respect to your profile and with respect to your path, what you do, you subtract it, the material, you remove it. So because of that, this is the cut sweep, and this is a separate option. So like a sweep, there is a sweep cut, you can directly go to insert, cut and sweep and you can get it, or directly from the tools you can execute and you can get this. And also if you have a solid body and a path, that also can be used for getting this kind of resultant feature. So here is the solid body like a sphere or maybe hemisphere, and there is a path, and with respect to that you can also create this kind of features that I'll be showing you right now. Open from your exercise file this particular reference file, and just like your sweep, here you can see something called sweep cut just side to this toolbar of this feature. And when you go to the sweep cut, here also the options are pretty similar, and there is also the thin options available, but it will remove material. So you have to go to this and you have to go to the profile. But here you can find one option like solid profile. I was just discussing the second case, and that you can do here. So let me show you that particular example where we can use that solid and refer that as well. So this is the case exactly. So let me remove this chord sweep and just restore this to the existing one. And this is my path. Just I can go for this as a show so that you can see this. So let me start with this chord sweep and I'll just switch to the solid profile instead of the sketch profile, and I'll go for solid profile, and this is very handy exactly. In most of the software you won't find this. This is specific to Solidworks, and once you select this particular feature and your path, that also will be taken care, and that will be act like a removing tool by following your path, and you will get this final output as I have shown. Thus you can try with this. Next we'll be looking at loft feature. This loft feature is one of the advanced tool where you can see multiple different cross sections as well as the multiple different uh, type of profiles and guides combination. So here you can see you have one protocol called profile and one called guide curve, and again you can have your start and end constants, you can have the centerline parameters, the sketch tool and other options that also you can have, and thin features as well, and curvature display which we saw in sweep case, that also is applicable here. So this is a very straightforward simple example where you have the profile 1 here and you have a profile 2. So profile 2 is something rectangular, whereas profile 1 is something circular, and you have something called connector, one connector. So by referring this you can create this as your output. And in other case, if you switch, so I was discussing this in my other classes, like in CATIA also, and you can see if this is the starting point and this is the starting point for this sketch, then it is going to twist. And if you switch this to this particular point nearest to this, then material will join and all the corresponding side will join properly and the feature will be created like before. So this twist you can fix by reallocating this starting point to a new feature. So preview of the loft feature after modifying the location of the connector and how to do that. And by default, if you see this case, this is the absolutely uh, standard case where you can fix it also. And all connectors also you can modify independently by moving or twisting around this, and you can switch it in between and you can get the resulting output that I will also be showing. And also if you have the start and end constants, here also you can have your sorts of rotation, and that you can apply in terms of degrees. Here you can see and start and end constant rollout and normal to profile options. When you select this also you can see that I will be also showing you. And some of the critical case where what you can do is when you have the uniform cross section like four side here and four side here, and in between how to smoothen it you can see here, and how to get that tangency, that also I'll be showing you. Let us look at Let us start applying this loft feature to this. So here is the loft, and here you can see the profile, and here you can see the guides, and how to do that. That is very, very important to follow the step. So what you need to do is when you go to this particular loft feature, and here you have the profile, you can select your profile, and you can select your profile too. And based on that, you can see this is your preview, and the loft feature is built, and you can create this. But I want to show you some advanced feature where you can see this particular green start button here and here. And if let us say I'll be altering this, then this part will be twisted. Just like that, if I'll be altering this as well, the part will be twisted, and maybe I'll allocate to this point. So that was the point where you can fix it, and you can reallocate this, and maybe little bit if you remove that material, alignment will be reordered. And you can have a center line parameters also, like a, a rib or the support, that you can also apply. But mostly you can see there is an option called as close loft, and this is not applicable for this kind. When you have a ring shape of object, then you can go for the close loft, and the starting end will be ended with the this one, because this is infinite and it cannot meet and close ever. So because of that, this is not valid in this particular case. But if you have a ring shape of object, or maybe the path is circular or curvilinear, then you can apply this as well. And another example I would like to show you is this this example, and where how to use that. If you go to the loft and select your starting and ending one, this, and here also you can see the same thing, like the twist and all. You can realign directly this. So these two green dots are nothing but the starting and ending parameters for joining, and accordingly other points will be referenced, and you can see your final output. And also let me show you one option here, and if you choose this particular option, what you can do is start and end constant. You can go for normal to the profile, and here you can see by default, and here also you can go to normal to profile, and this will be the output. And if you go to direction vector, you can give a direction vector like this, with respect to which direction vector, because this is ambiguous here, there is no meaning of this, so it won't produce anything. So what you can do is you can try with this normal profile for both the direction, and you can see, or you can switch off any one point, either start or end. This is the end. So let us say I'll switch off end point. So which is your starting? You can see this is your starting, and this is your ending sketch. With respect to starting, this is done, and then this is connected in normal way. Or if you go to normal to profile here also, this will be normal to the profile here. Exactly, the tangential constant is applied, and we can finalize this. So these are the two different comparisons of the configurations between the circular to rectangular, or both are rectangular, and you can find and you can fix the required thing by switching the starting point as well. So next we'll look at some of the advanced options where you have multiple sections, section number 1, 2 and 3 with 4 sides each, and how to connect this and control different tangency. And I was just discussing before about the closing option. So here when you have more than one and not linear, so there is a possibility of closing this also, this end. So how to do that? So even in fact it is not a circular path, but this is curvilinear, so you can apply this. And also how to control the start and this end profiles tangency, or you can say the normal vector configuration, that also I'll be showing you. And this is what I was intended here to show you. So how to configure the tangency option at the start and end section, and the final loft is something looking like this. Let me show you. Open your file from your exercise folder, and go to your loft and select your profile number 1, 2 and 3, and here you can see this is something looking like this. And when you go for this particular option like start and and constant and go to direction vector, and this profile's direction vector I want to give this vertical direction, so that this is the direction vector. Just like that, the direction vector for this profile, this is the end constant, is also along this direction and this. And now you can see this is controlled and this is the output which we are looking at. And also, if you look at this closed loft which I was discussing before, that you cannot apply in infinite to parallel sketch, but here you can. And like this, you can end up with this another bottom part where you can have another loop as well. And finally, you can finalize this. So these are the options which will be handy for creating complex objects with contours. Next, we'll be looking some advanced option where the combination of your profiles, this is the profile 1, this is the profile 2, and this is the profile 3, as well as the guide curves. You can see guide curves. You have the 4 different guide curves. So by using this combination, how you can create the loft, and here you have the variation of different sketches, here 2 circulars, and here you have multi sided, and here maybe octagonal or hexagonal or septagons or whatever that you can configure here. And another case we'll see that how to map with respect to your path and 2 different profiles, one is circular and one is rectangular, and get this kind of shape. And some of the other operations like this we saw before, and how to apply a thinning operation and how to close the loft, that also already have shown. You can just try doing it and close loft options. Let me show you. So here what you can do is, if you go to loft, here we have not yet used this guide, but let me start with the profile 1, 2 and 3. And also if you go to the guides, I'll start with my guide curves, guide number 1, guide number 2, guide number 3, and this is my guide number 4. So in this way, what you can do is, here you can see this magenta color are the indicator or the reference for your start point, and here you can see the preview. This is the preview, and if you edit it, you will find some options like center line parameter. If you have a center line here also, that it can follow. And here in fact close loft is not available. And start and end, you can go for the direction vector or normal to the profile, here you can see. Or end also, you can go to normal to profile, and that smoothing effect will be updated, and that will be very normal and smoothened to your start and end profile, and you could able to form this kind of shape. Let me show you the other case. And for using this, you have to open this particular condition, and where you will go to the loft profile number 1 and profile number 2, and I'll be going through this path. So what happened here is, if you go to this particular sketch or this particular sketch, this particular sketch, somewhere the starting and ending point reference are not correct, and based on that you could not able to form this. Then how to fix that? That is one point here. So let me add this under the sketch, and this is your path, and how to fix that. That is one of the challenges in this particular case, and this is very simple. Just you have to follow the fundamentals. So let me show once again. Profile 1, profile 2, and now we are adding one constant, but then is vanishing, and you are not able to see the final output. Here you have something called the guide curves to the next sharp or to the global, that you can switch also. But primarily I'll be looking at this forming this particular part. So you may be wondering why this is not forming. So it will never form. So fundamentally, if you go to the next guide, so we next sharp or whatever option, so this is not valid actually. Guide curves influence type. So why this is not forming is, I was just discussing before that center line parameter. This is the place exactly where you have to go for a center line parameter and remove this guide curve. And if directly go to a center line parameter and fix this directly, just let me remove it and go to the center line parameter and give this, and directly you could able to see the final output. And here you can see the green dots where you can switch also for twisting related discontinuity, and you could able to. So this is center line parameter. This you have to use it. So if you try using this guide curve, you will never get the solution. So be careful. So I was discussing and trying this, and again here what you can do is if you just go to edit and here you go for the particular other operations like close loft, here you can see this is not applicable because this particular end if you move and this is not in a continuity, there is no tangency here. So this again if you'll go, it will have an infinite loop to the end other end, so other end is not in line with that, so it will not show or suggest that as well. So just you can try and understand this kind of projects and the issues I was discussing. Another great example of closed loop is this one, which before also I have shown you. But if you have multiple sections like 4 sections and then you go for the closed loop, then that can directly form you a closed loop. Only this is the basic case, but just you can try and see this. And this is one case of your loft where you can have your thinning here, loft thin, and this loft thin you can use, which will be handy when you have material removal requirement, and that can be used here. Let me show you how to do this. So let me just delete this first, and these are my sketches. So directly go to loft and select your sketches 1, 2 and 3. And also what you can do is you can start doing this direction vector, where I can give my direction vectors for the starting point and also for the ending point. I'll be looking at this, and now you can see the thin feature is activated, and you can give your thickness, let us say 2 mm, and I can finalize. When I'll finalize, what is saying, the feature could not be created because it produced self-intersecting. So there is a problem with the starting point. Let us fix this. Okay, so this is the green point, so that you can fix it. So anytime it is not properly connected, so you can give that, and this is your output. So the operation or the feature will be listed here, something called loft thin. So this is done through the same loft, but like your sweep cut, by default if you remove it, sweep cut will not be highlighted. So this can only be applied when you have a feature existing. So you can only go for this, and within that you have that particular operation for cutting. So in our coming classes, we'll be discussing about more loft advanced features like this, how to customize and create it and create 3D sketches like this, and how you can primarily create critical sketches like this of one which is shown here, and also how to manually create that and finally create the curves and then map that with a different height protocol, and then create a reference grid for our project. And these are the corresponding operations which we'll be discussing in our coming classes, and creating split lines, the shill out, and how to use a projection for creating critical curve, and also the split lines, this concept, intersection concept, creating composite curves, and then the creating composite curves through XYZ locations and mapping that by using different points which are listed here in the curve file, and then creating the reference point as well, and how to create the complex 3D through reference vertices, and how to create equation curves. That also will be discussing, like the helical and spiral or the conical taper helix, and also how to extrude 3D sketch. That also will be discussing, and creating draft features and other related operations there. And then we'll be looking into this particular project where your task is to create this particular output by using the sweep operation, and the step-by-step explanation will be done. And in project 2 we'll be creating the directly curves, 3D curves, and in project 3 we'll be creating a spring as shown here, and how to create through equations, then transforming that and attaching another curve and getting the final thing done. And in homework, couple of homeworks you have where you will be creating this lofted feature, and this also you'll be creating, and this another homework where you will be creating this particular feature. The dimensions are given here. And let me discuss about the deliverable. The deliverable is straightforward. We will be giving all the modules part file which I'm using currently, and showing assembly files as well, drawing files, and lifetime support related to technical doubts. You can directly write to support @smartlearningindia.com, or maybe 24/7 @smartlearningindia.com. And we'll be also giving you drawing PDF copy and tips and tricks session with all the modules for increasing productivity. All modules video license file also will be given to you. Thank you.